Hi, I was hoping to explain some instructional procedures and the whys behind them when it comes to an abstract concept such as multiplying two fractions. So, pause the video and take a minute to read the problem on the screen. Okay. Hopefully, you were able to mentally digest what the question is asking, but you may be a little rusty with fractions, and that's okay. Hopefully, by the end, you'll be up to speed. So, we have Cadence baking a cake. Two-thirds of her cake has purple icing, the rest has orange icing, which is the sentence most kids ignore. And then Cadence decides to put sprinkles on only a fourth of the third. So, what fraction of the cake has sprinkles on it? Well, lots of kids come up with this equation, which is not the correct equation, and it is not the right answer either. So, what's happening is kids are looking at the two numbers, two-thirds, a fourth, reading the last fraction or reading the last sentence, coming up with a fraction. So, if you can cover all the words, almost all the words in a word problem, and just pick out the numbers and know what to do, then the problem isn't promoting real math. And it's probably not constructed properly. And so, what we want to do is we create these types of problems so that kids are truly understanding what is happening, right? So, like, you need to understand fractions to be able to solve this problem. And one thing that helps with visualizing fractions or visualizing math in general is to have a model. So, here we are with a tape diagram. We have two-thirds of the cake has purple icing and the rest has orange. And if you draw out a cake and break it into thirds and two-thirds are purple, you will automatically see that the last third is what's left, right? So that's orange. And so Cadence decides to put sprinkles on a fourth of the third. So you need to break the last third into four equal pieces, and that is where the sprinkles will go. And then now students can see that we are using the equation a fourth of a third, right? And so they come up with a 12th. And so this tape diagram doesn't do a great job of visually explaining why that 12 is there unless they break every third, and they know automatically to break every third into four equal pieces. And we'll talk about that later. But I just want to point out that order is important for context. So if this is a quiz or a test and a student says a third times a fourth, then that's going to be a point off because that's not showing that they conceptually understand that this is a fraction of a fraction. So in this context, right, the sprinkles is a small part and the third is the bigger part. And so the equation reads a fourth of a third, which is what the visual model shows. And so if the order was the opposite, a third of a fourth, it wouldn't match the picture, which doesn't match the story, which means whoever's reading it and producing the problem didn't truly understand what is happening, right? Which is important when you get into higher math. So if students can't visualize what's happening in the correct order, then they don't really understand what's going on in the math. So that was the tape diagram, and this is the area model that I'm getting ready to show you. It starts off the same way. However, visually, you will now understand why when you multiply two fractions, the bottom number is new. So you have two-thirds. I left blank because we don't need to know anything about the purple. And then we have a third, which is orange. Now I'm going to break the entire area into four equal parts because if one third is broken into four equal parts, every third needs to be broken into four equal parts because fractions are equal parts of a whole. And so then you identify the fourth going all the way across, and then which piece or pieces have been double identified, and it is going to be the 1/12th, which is visually how you get 12 pieces, right? And then the last model that we've been working on in school is using the number line. This is one of my favorites because it really helps me understand, do kids understand the equation? So if you're looking at that specific equation of a fourth of a third, that means you're looking at thirds, right? So here my thirds are on my number line, and I have 0 to 1 because 1 is the whole in this case. So then I need to understand that if I'm looking at a third and I isolate a third, my third needs to be broken into four equal pieces. And then what do I know about fractions? They're equal pieces, so every third has to be broken into four equal pieces. 4 times 3 is 12. That's my denominator. Then I've isolated the third into four equal pieces, and now I have 1/12. So I really enjoy the number line. That doesn't work for everybody, and that's okay. Some kids love the tape diagram. Some kids prefer the area model, and that is okay. But we've got three different visuals. to explain our thinking. And really what we're doing here is we're connecting students' knowledge of multiplicative thinking with fractional knowledge. So if we have 3 equal parts in one, which is thirds, right? And you break one of those thirds into 4 equal parts, and that you understand that because fractions are the same size in a whole, that means every third's been broken into 4 equal parts. So then, 4 3 times is 12. I hope this was helpful. If you have anything else that you would like us to show, explain, or model, please let us know, and we will get that out to you.